Hey guys, so we're going to be looking at some examples on how to solve quadratics by square roots. So I assume you're up to date on how to simplify radicals. If not, you can check out my other video on that. Once again, it's really important that you know your perfect roots 1 through 20. If you have to, write them down, do whatever it takes, but it's really important that you know these. Okay, so when solving quadratics by using square roots, what we want to do is we want to isolate the x squared, meaning we want the x squared to be all by itself. So in this case, how we can get x squared by itself is we can add 64 to both sides. Okay. Then we're left with x squared equals 64. So now there's just one last step because we just want x by itself. We don't want x squared. How you get rid of a squared is you take the square root. Okay? And if you do to one side, you have to do to the other. So anytime once you get x squared by itself, you're just going to take the square root of both sides. Over here, since we took the square root of a squared, those cancel each other out. So on this side, we're just left with x equals. Okay, and then we know from our chart that the square root of 64 is going to give us 8. And then if you remember, anytime you take the square root of something, you're left with a negative and a positive version. So here's the answer for that one. Let's take a look at number 2. Okay, so once again, before we can do anything, we have to get x squared by itself. So I'm just going to start doing that. We're going to start by subtracting 3 from both sides. Then we have 9x squared equals 108. Now we need to get rid of the 9. And since they're attached, we're going to have to divide it. If I divide one side, you have to divide the other. Those cancel out. We're left with x squared equals 108 divided by 9, which is going to give you 12. So now, once again, now that we've got our x squared by itself, we can just take the square root of both sides. So the square root of x squared, like I said, a square root cancels out a square, and so you're just left with x equals, we have the square root of 12, okay? But we can break down the square root of 12 because we can break it down with a perfect root inside of there. So the square root of 12 can be written as 4 times 3. Of course, we used 4 because it's a perfect root. So we know the square root of 4 is 2. And then we still have radical 3. Okay, so our final answer is going to be x equals, keep in mind it's a positive and a negative, 2 square root of 3. And once again, we can't break down the square root of 3 any further just because nothing times itself will give you 3, so that's the simplest version. Okay, let's look at example number 3. Same thing, we're just trying to get x squared by itself. We're going to start by subtracting 5 from both sides. So we have 81x squared equals 16. And then, of course, divide by 81, divide by 81. We're left with x squared equals 16 over 81. Okay, and it's okay to get fractions because sometimes you will come across those. So now we are left with the x squared. So we're going to take the square root of both sides to cancel out that squared. Then we're left with x equals the square root of 16 over 18. If you remember, when you get a fraction under a square root, you have to break it up into the square root of 16 over the square root of 81. We know that the square root of 16 is 4. We know the square root of 81 is 9. So our answer is going to be x equals plus or minus 4 over 9. Make sure you always remember, anytime you take the square root of something, you're always going to get a positive and a negative version.